So now we have found out the position vector of the center of mass. Now let's spend some more time, just some maybe 3 to 5 minutes to understand what is this implies physically. See, we know that the center of mass is the balance point of a system, right? Or it can be said that it is a weighted average of all the positions of the respective masses. Now, when we consider a two mass system, okay, when we consider two mass system, if both objects have equal masses, the center of mass is in the midway. But if one object is heavier, the center of mass will shift towards that object, the heavier object. Now, why do we use vectors? Because in 3D space, we need vectors to track x, y, and z, all the three coordinates. And we know that the corresponding position vector of center of mass will be given by m1 r1 plus m2 r2 by m1 plus m2. Again, we are specifying only a two mass system. So, when we consider mass 1 at r1 and mass 3 at r2, what did we derive the value of vector rcom as? Rcom was derived to be minus 2y, right, minus j plus k cap. Now let us try to understand the relationship between r1, r2 and rcom. So we know that the center of mass will always be closer to the heavier mass. Now, when we say that center of mass is closer to the heavier mass, it is applicable along the x, y, and the z direction as well. Which means the x coordinate of the center of mass will be closer to the x coordinate of the heavier mass. The y coordinate of the center of mass will be closer to the y coordinate of the heavier mass, and likewise with the z direction. Now, if we were to write r1, r2, and r center of mass and analyze the x coordinate and y coordinate separately, the x coordinate of r1 is 1, the x coordinate of r2 is minus 2, and the x coordinate of center of mass is the x coordinate of r2 was minus 3, and the x coordinate of rcom is minus 2. So compare these x coordinates. The center of mass is closest to the r2, which is the heavier mass here, right? So the mass, this mass is, so r1 is of 1 kilogram mass and r2 is of 3 kilogram mass, right? Now, so say this is 0, 1, 2, minus 1, minus 2, and minus 3. The position of r2, the position of the position of r1 is over here. This is r1, right? Or this is mass m1. Where is mass m2? Mass m2 is at minus 3. This is where mass m2 is. And where do we find center of mass? Center of mass is over here. This is where center of mass is located. So the center of mass is located closer to the m2, which is the heavier mass. Okay. Now, why are we discussing these concepts after solving the question instead of just solving the MCQ? Why are we going one step ahead of this? here is to make sure that we are ready for a question which is based on assertion and reasoning, which comes out of maybe which can come out of these concepts, or maybe these out of these these tables, or any such question that can be put up in the form of assertion and reasoning, which is not just about solving MCQs. It is also about understanding the given statements and the concept behind it. I hope that makes sense. So, yes. Now moving on to the next question, which is a typical question based on both integration and physics, based on continuous mass distribution.